Okay, here we are in workshop 6.1, Intro to Radicals. Please take time to pause this video, and I know this is kind of unconventional from what we normally do, but copy all of these examples down as they are. You don't need a ton of room to work. They're going to be pretty much one-line answers. Pause the video and copy those down. Okay, let's work our way through these. It's primarily a review from Algebra 1, and I'm going to add a couple new things here as we get into example 3. Square roots. Square roots, working primarily with perfect squares and perfect cubes throughout this assignment. But the square root of 36 is 6. It's the number times itself twice that will give you the number that's in the radical. So that's how square roots work. We have a cube root of a negative 8. So that means what number times itself 3 times is the negative 8. And that would be a negative 2. By the way, if you ever hear me say the word index, the index is what's inside the root. It's a 3 here. If 1 doesn't show up, it's a 2. That's called the square root. And the number inside the radical is called the radicand. So index and radicand might be 2 words that you hear me say. In C, the square root of 1/4, when you take the square root of a fraction, you just take the square root of the top and the square root of the bottom. The square root of 1 is 1. The square root of 4 is 2. So 1/2. In D, the square root of a negative 16. It'd be the square root of a negative 1 over the square root of 16, but the problem with that is you can't take the square root of a negative 1, so you should write not real. Don't use the no real solution sign. I know that's picky because you're not solving anything. There's no equal sign, so it's not no real solution. It's just this is not a real number. In E, notice that the negative sign, there is a little negative sign there, has moved outside of the radical. So you're just going to attach that to what the square root of 1 over 25 would be, which is 1/5. So hopefully you look at all of those and they're really relatively easy. As we work our way through example 2, when you square radicals, it undoes them. So you have the square root of 11 squared, that becomes just a normal 11. And the negative squared will become positive, so 2a is 11. 2b, you're now cubing. When you cube a negative, it's going to stay negative. Negative times a negative times a negative is a negative. When you cube the cube root of 13, it becomes a regular 13, just like happened with the squares. Notice in C, the negative is outside the parentheses, so we leave the negative, squaring only the square root of 11, which gives us a negative 11 for our final answer. So there's how you're attacking and approaching those first two examples.